draw resonance structures. Resonance structures are different forms of the same molecule where the only thing that changes is the location of electrons, and electrons only. A molecule is at the same time a hybrid of all of its resonance forms. So how do we show resonance forms? There are two major patterns that we have to keep in mind when we do this. Let's go ahead and look at the first pattern. The first pattern is, and let me just make my pencil a little thicker. The first pattern is if I have a double bond next to a positive charge. If I have a double bond next to a positive charge, I can show the following resonance. I can move my electrons from the double bond here. And by the way, what do the arrows mean? So an arrow means that you're moving a pair of electrons. An arrow will come from something that has electrons, such as a lone pair or a double bond, and it will go somewhere to a place that can accept electrons, such as carbocation. Carbocation has a positive charge because it does not have enough electrons. So in my first pattern, I can move electrons here, and for resonance I draw a double way arrow, and let's see what happens here. This double bond is no longer there. The electrons from the second bond move to make a double bond here. This carbon is now happy. It has no charge because it got a pair of electrons, but this carbon is now missing one of its bonds, so it will have a positive charge. This is one of the main patterns that we can recognize in resonance. Now let's see, do we see anywhere here a double bond next to a carbocation? And I can see, oh yes, this molecule has exactly that. We have a double bond next to a carbocation. So how could we show the resonance? Again, we move our arrow from the double bond here, and my resonance structure will have now a double bond here. These electrons move here, and now this carbon at the end lost electrons and will have a positive charge. Remember, electrons always move from something that has electrons, such as lone pair or double bond, to something that could accept electrons. And sometimes for our resonance we have two arrows as well. We will see that pattern as well. Now I notice here in the second molecule that I have a positive charge as well. That means that I could give it electrons. But what in my molecule has electrons to give? If you see atoms other than carbon, such as oxygen or nitrogen, we have to show its lone pairs. Here they're not shown to make sure that it has an octet. Octet is 8 electrons. So looking at my oxygen, I have 1, 2, 3, 4. I have only 4 electrons right now, but it should have 8. So I give it 4 more electrons, 2 lone pairs. And now this molecule is happy. And now I can see who can help my positive charge. What kind of resonance can I draw? Again, an arrow from something that has electrons to something that can accept electrons. So what do I have here? I have electrons, and this carbon can accept them. So I can go like that. And let's see what I will create. So now I have this. I still have 1 lone pair of electrons left. I still have 2 electrons left. But now I have a double bond here. This carbon, because it accepted electrons, is no longer positive. It is happy and satisfied. But this oxygen is now sharing its electrons, so it will have a positive charge. And if you're not sure how I'm getting these positive charges, you can watch my video on formal charges to see how to calculate them, because we can easily calculate it, especially in the beginning if you're not sure. So this is my second resonance. Now in this case I don't really see any positive charges, but there is another pattern that I have to show you. and that pattern will be a double bond next to a lone pair. So if I have a double bond next to a lone pair of electrons, my resonance can be shown the following way. I will move my electrons this way to create a double bond here, but now this carbon has too many bonds. Remember, it has a hydrogen that was not shown here. I'm just going to show it. And if I give it a bond, it has way too many bonds. Our atoms, such as carbon, cannot have more than 8 electrons. So how can I help it? By drawing another arrow to the following carbon. Let me just go ahead and show all of the carbons. So this pattern is a lone pair next to a double bond. If you notice that we have a lone pair next to a double bond, we can move electrons from the lone pair to create a double bond, and from the double bond to create a lone pair. Let's go ahead and look at that. So here, and I will again draw all of my hydrogens like this. I didn't draw the hydrogen here, but let me just make it more beautiful. So what does this mean? This arrow means that I took my 2 electrons and I made a double bond here. Now my carbon will be neutral. Again, you can always check the formal charge, but it used its electrons to share it with the second carbon, so now it's neutral. Now for this double bond, it's no longer there. I moved the electrons to this carbon, so I move it here, and now this will have a negative charge. Notice these are kind of similar. Basically, you had double next to a carbocation, now carbocation next to a double bond. You had double next to a lone pair, now lone pair next to a double bond. So they kind of switch around. So this is my second pattern, a double bond next to a lone pair, and I have shown that you need to show 2 arrows, and this is my product. Let's see if this is the pattern for this problem. I do see a double bond and I see an oxygen. Again, I'm going to add electrons because they're not shown. I'm going to show them to make this oxygen have an octet. It has 1, 2, 3, 4, so 5, 6, 7, 8. Now it has an octet. These electrons were not shown, but I have shown them so that I can do my resonance better. And what do I do now? I notice that I have a double bond next to a lone pair of electrons. A double bond next to a lone pair of electrons. Let's highlight it. What do I do when I have a double bond next to a lone pair of electrons? I don't really have space. I guess I will go this way. So I bring my electrons here, and this pair of electrons go here from the lone pair to make a double bond, and from the double bond to make the lone pair. Now let's draw my product. I have this oxygen will have a positive charge. Again, we can check the formal charge. It is sharing one of its lone pairs with the carbon. It created a double bond. And this double bond is no longer there. Instead, we took electrons from the second bond to give a lone pair to this carbon. And now this carbon will have a negative charge. This is Maya Lochi. Let's continue going through resonance problems in my next video.